Now we start with vertical projectile motion from the beginning. What you need to know always. The first thing you need to know in every chapter is those are your definitions. We have only two definitions from vertical projectile motion. And the first definition says is the free fall. So the examiner will expect you to define free fall. So you are expected to define the term free fall. What is meant by free fall? Free fall, from the examination guideline, I just adapted it a bit. It says the motion of an object upon which the only force acting is the gravitational force. So free fall is when an object is in motion, but the only force acting on it is gravitational force, and we refer to that as free fall. That means there's no applied force acting on an object. There is no frictional force acting on an object. There is no tension, no any other force. The only force we expect to act on an object is the gravitational force. Then that we term it free fall. So that is definition number one. Definition number two is a projectile. Now a projectile, we define projectile as object upon which the only force acting is gravitational force. So the two, they are quite related. When I have this thing, when I throw it in air, when it is in air, it is called projectile, but the motion it executes when it is in air, that motion is called free fall. So sometimes you might refer to this, the term free fall, as projectile motion. So this is the motion of a projectile. The motion of a projectile it's referred to as free fall, and we define it as like this. To remember, we memorize definitions. If you are struggling with them, just make sure you memorize them, because you are going to be expected to reproduce them in a test. If you look at the first definition, if you memorize the first definition, the second definition is actually integrated with the first one. From the part that I've highlighted is actually the second definition. So they only differ by the first three words. This one, free fall, will be motion of an object, and projectile will be the object upon which the only force acting is gravitational force. Let me see. If you use the term an object that is experiencing free fall, nope, the examiner will not. Oh, okay, it's not incorrect, but then we don't accept that one marking. Or in marking center, we accept. You must mention that this is an object, and the only force acting on this object is gravitational force, and you should mention the keyword only. So you should put it in way. So if you say object that experiences free fall, it still leaves loopholes, because someone might not remember. When you explain something, you are explaining to scientists. Yes, to your science teachers. The people that are marking you are they are science teachers. But there should not be a doubt in your explanation. You should leave no stone unturned. So if you say an object upon which the only force acting is gravitational force, that will be correct, and you get 2 marks for any definition. Check it also in the exam guideline. Normally we advise you to define these scientific terms exactly as they are stated in the examination guideline. So we try to put it like that. But these two, yes, check out the past papers in the memorandum. You'll see whenever they say define free fall, you'll have motion of the object upon which the only force acting is gravitational force. Excuse me. So what does this mean? This means that the acceleration of the object is 9.8 meters per second squared. Remember, the only force acting on an object will be gravitational force, and we calculate gravitational force using the formula Fg is equals to mg, where will be the mass of the object and this is the gravitational acceleration. So it means that the acceleration of the object is exactly 9.8 meters per second squared, and the direction of this acceleration is always downwards. These three things, people, this is a definition for 2 marks, another definition for 2 marks. This is an exam question. The examiner, they like asking you the acceleration of an object at any point. The acceleration of an object during free fall does not change. It remains 9.8 meters per second squared, and it is downwards always. So these are 2 marks, 2 marks each. You can formulate questions on them in a test. So just keep that in mind. When we are dealing with question 3 of the grade 12 question paper, we regard acceleration to be 9.8 meters per second squared downwards always, all the time, at any point of the motion. It does not change. So this should be always. Acceleration will be 9.8 meters per second squared. Now let's study the equations of motions that we'll be using. As I said, this chapter is actually one of the shortest topic, but it has a lot of things in it. It's very short. There's we don't have a lot of things to explain. There are 4 equations of motion. Actually, the first equation of motion is the one that says final velocity of an object equals to initial velocity plus acceleration change in time. So we need to define these physical quantities. This one is called initial velocity. And velocity, remember, velocity is measured in meters per second. And VF will be final velocity, and is also measured in meters per second. Change in Y. In grade 10 we had change in X. In grade 12 we have change in Y. Change in Y, this is your displacement. And this is measured in meters. Now, the issue of displacement, the issue of initial velocity and final velocity is not that much of a problem, but displacement confuses a lot of you. Let's explain what we mean by displacement. If this is point A, the object moves between the 2 points, point A and point B, like that. This whole thing will be the distance, and the displacement will be the straight line between the 2 points, starting from where it starts. This is the start, and this is where it ends. It stops. So the displacement, this will be your displacement, the straight line distance between 2 endpoints. We don't consider the object went that way, to the right, down. That part is not useful to us. We only want to identify the initial point where it starts and the final point, and then we draw a straight line starting from where it starts, and then the arrow will put the arrow where it stops. So that will be displacement. So for an object that went from point A, let's say point A to point B, and then later to point C. The displacement in this case will be, it started here. This is when the object starts from A to B, from B to C. If this was okay, the values will not matter much for now. If this is where the object starts and it stops at this point, the displacement will be a straight line distance between point A and point C. This is it's quite important to understand this, because as we do more calculations, it becomes, the issue of displacement becomes a little bit tricky, especially when the object is being thrown up and then it comes down, and there's a lot of technicalities. Just know this. You don't need to remember this, you have to know it, that displacement, it is measured from the starting point to where the the object stops, and the straight line distance, straight line. No, we don't consider what it went via point B then to C. No, that is not important to us. We just want the initial and final point. And actually, change in Y, this, remember, it will be Y, the final position minus the initial position. So it makes sense not to consider point B and point C, because the final position is this. The final position is point C. The initial position is point A. In this diagram, the final position will be point B. The initial position will be point A. So displacement is just a straight line between 2 points. Just remember that this is coming from the knowledge here, from the same topic of grade 10. So displacement, it is measured in meters. Then we have the time, change in t is, that will be the time, and acceleration, this will be acceleration. So I'm not, let's just write it. This is 9,8. Always this is given, meters per second squared. Remember, velocity is meters per second, but acceleration is meters per second squared. And the direction of this velocity, of this vector, is downwards, downwards always. And this is always. So don't, not at any point will it, no point where this value will change. This point remains like this for forever, for the rest of your grade 12 and beyond grade 12 knowledge. Acceleration remains 9,8. We approximate it correctly to 9.8 meters per second squared, even though this value is almost the value at the poles, but we will take 9.8 meters per second squared downwards. I believe we are still fine. If you have a question, you'll indicate. If I'm moving too fast, you'll also indicate that I'm moving too fast. So let's continue with the equations of motion. These equations are given in the formula sheet. It says final velocity equals to initial velocity plus acceleration change in time. That is the first formula. The second formula is final velocity equals to initial velocity plus acceleration plus 2 times acceleration and multiplied by displacement. And the third formula is the displacement equals to the initial velocity multiplied by time plus half acceleration change in time squared. And the final formula is displacement equals to the average of the velocities multiplied by time. So this is initial velocity plus final velocity divided by 2 change in time. So remember, there are a lot of marks for, we are, if you know your definitions, if you know your definitions, you are securing marks for the 2 marks, any of the 3. If it comes, you secure the marks. Make sure that you get all those marks. You don't lose marks mark definitions. No one should lose marks definitions. Those are free marks. Another set of free marks will be our marks on our formulas. Formulas are awarded 1 mark. If you write the correct formula and then you use it, you get 1 mark. But if you write the correct formula and don't use it, no mark given for you. You must write the correct formula and you should use it. So how do you make sure these formulas, we find them in formula sheet? In the grade 12 formula sheet, it looks like this for paper 1. We find them under the table Epale motion. So look for the table that's written motion in your formula sheet. And these are the formulas we have. The first formula that I've shown you, this one. It is this formula that says VI equals to V final equals to VI plus acceleration change in time. And then the second formula will be this one. But notice, like, it says change in X, and in grade 12 we are considering motion in the Y axis. So I would rather choose this one, the second one. We'll choose that one. And then the third formula will also choose carefully, the one that says acceleration change in time. It's the same thing, one and the same thing. You won't be penalized for writing change in X in grade 12, but it makes more sense that we are dealing with motion in the Y direction. So why choose the wrong one? Why choose the one that says change in X? So yep, it's that's what we have. Those are the formulas we have. The other ones will work well for grade 10 motion. Otherwise, grade 12 we use change in Y, and then we keep it like that. So this is a formula sheet. Keep the formula sheet next to you all the time you're studying physical science, so that you know where you get the formulas. You don't spend the whole time fiddling with paging through to identify the correct formula. So now, before we go into calculations and solving problems, we need to understand the next thing, which is equations of, not equations of motions, the graphs that come with this chapter. There are 2 formulas that give us a graph. The first formula will give us the velocity time graph. The third formula will give us the displacement time graph. So let's write them down. This will be velocity time graph formula versus time. If you have to draw a graph of velocity versus time, you know that this formula is the one that gives you the correct graph. And if you have to draw displacement versus time, this will be the correct formula for that. So mark these two formulas. They are quite important in our study of this chapter. They help us a lot in drawing graphs. For those of you that your strong point is mathematics, you'll notice this is a straight line graph. So whenever we draw a velocity time graph, we expect to find a straight line because there's none of the physical quantities is squared. We are plotting velocity against time. So it's a straight line graph, and it's final velocity against time. So just keep that in check. For those that same group of people, this will be that we are plotting displacement against time. But now you notice that there's a time factor there and a time squared factor there. So this means that this is a parabola. It's a graph that will either look like this or look like this. But we forget, we discard the other part of motion, depending on where do we start to begin our motion. But yeah, graphs, parabola graphs for displacement time graph. The acceleration time graph, remember, acceleration does not change. It's 9.8 meters per second squared, so it does not matter what happens to time. The acceleration vector it remains the same. So let's look at a couple of scenarios and see how these graphs will look like. For an object that is dropped, so an object that is dropped in this ground, the object will move in that direction, and finally it will hit the ground. Later on it will hit the ground with final velocity, which we don't know now. We will need to calculate it. But if it is dropped or it is released from rest, the initial velocity is always zero. Initial velocity is always zero, and this will be the height of the object. The displacement will start. The object, remember, is dropped from that point there. It comes to the ground. So the displacement vector will be in that direction. So we are just understanding this situation. So the graph, you are expected to draw three graphs. Firstly, the displacement time graph, the velocity time graph. But the displacement time graph for this one, let's just what is important is the shape, because you get 1 mark for the shape of the graph, and you cannot lose marks on the shape of the graph. So this displacement, so delta y versus time, since it is dropped, we choose direction. Always when you are dealing with vectors, you must choose one of the direction positive, one of them negative. This object is dropped, so let's just choose down positive. So we take down positive. So we take down positive. It starts from some position there. If there's two ways to draw it. I'll show both of them. A displacement time graph. Displacement versus time. Okay, just time. So we have time in seconds, and this side will have displacement in meters. Always in the y-axis, when it's displacement time graph, we have displacement in meters, and then on the x-axis you have time in seconds. I hope that's still visible there. So this, what happens when you choose where the object begins as your starting point, as your reference point. So this is top as reference. So the object, it means the object is starting from its zero reference. Remember, when you say a point is a reference, it means we put a zero there. So it starts moving at zero. As time increases, the object it moves down. And notice the shape should be like this. The shape will look like this because it's a parabola graph. It's a displacement time graph. When you choose the top as the reference and we choose down positive, so the object, as it comes down, the displacement increases in the positive direction, and this will be the displacement when it reaches the ground. So some displacement, some final y, the y final, the positive. If we choose the ground as the reference, so now we make ground as reference. Remember, I'm just making sure that we are polishing the issue of the shape. The shape should be correct. if we choose the ground as the reference, your graph, it means your 0 is here, and then this is a point above the ground, and you're choosing down positive, so your graph will start somewhere there. The shape is maintained, ne? We're choosing down positive, so the ground is there, is where your 0 is, and that part is your it's because it's above the ground and the object is not going that direction, it's coming down. It's a point above the ground, so that point will be a negative position. So your graph will look like this, because that point is some y value that is above the ground, so it's negative because you're choosing the ground as your 0. So the graph, the shape of the graph is the same, just that we're shifting the position, the reference point. If you make the reference point where the object starts, you shift the graph up, it becomes like that. And there we have it. When you have the ground as, we're still choosing down positive, remember we chose down positive, so the shape will be like that. Now with the green, I'll draw when you choose the same graph, when you choose the ground down as negative. So green, now I want to write, but it's going to be messy if I write on this one. No, let's not complicate it on this same graph. It will be quite messy, but the shape will be the same. If you choose up positive, this graph will come this side. The same shape is maintained, just it goes down like that. And the same la, if you choose so it's this graph, if you choose the ground as the reference point, you push this graph up, and then the graph will look like this. So it's they are mirror images of each other about the x-axis. So that's what happens to the shape of the displacement time graph. Now, what will the velocity time graph look like? The shape of the displacement time graph of an object that is dropped looks like this. Any questions so far? We're still fine. Please like the session and follow for those that are not following yet. So let's move it up a bit, and for the same motion, now discuss the issue of velocity time graph. Remember, we're just securing the arrow mark for the shapes of this graph. The velocity time graph will be velocity versus time. Let's say the velocity versus time. On the x-axis we have time in seconds. On the y-axis we have velocity in meters per second. Remember, we said velocity time graph is given by a straight line because the formula looks like this. The formula looks like this. This is given by a straight line. For an object that is dropped, notice that the initial velocity of the object is 0. So it means this part is 0. You're just plotting final velocity of the object against acceleration multiplied by time. So if you choose down positive, let's choose down positive, notice that the object will start from this point. This is your 0 point, as this is velocity. And velocity increases to the positive that way, and it increases to the direction negative that way. So the object starts here. As it goes down, because you chose down positive, so it means the velocity increases. So the velocity is a straight line, and it increases like that. The shape is like that. And this will be the final velocity when it reaches the ground, and this will be the final time when it reaches the ground. This is when you choose down positive. With velocity, there's no reference point. You just need to know what the initial velocity is, the final velocity. It's a straight line like that. Now, if you choose up positive, let's use a different color. I hope that's visible. If you choose up positive, so you still have the same shape, but now when you change direction, they mirror each other on the x-axis. So this is up positive, and this is time in seconds, and this is velocity in meters per second. So the shape looks like that. And this will be the velocity, negative value of the velocity, because now we're choosing up positive, so it means down is negative. As it goes down, it accumulates the velocity, but in the negative direction, and the shape will look like that for an object that is dropped. Acceleration time graph remains the same for all the shapes. I'll do it once, and then you just keep it in mind all the time. So this is velocity time graph, acceleration versus time. For acceleration versus time graph, you just need to choose the direction. That's all that is important. It's a straight line. If you choose down, so let's say down, positive, it means your acceleration value is still remains the same value. It's 9,8 meters per second squared. What we said always, as time increases, the value of acceleration remains the same, meters per second squared. So we choose down positive and the acceleration value is going downward, and this will be 9.8 meters per second squared. Now, if you choose up positive, if you choose up positive, the graph remains the same, the shape is maintained, just that now this will be negative 9.8. This is time in seconds, and this is acceleration in meters per second squared. So this is the shape of acceleration time graph, always doesn't change. The value of acceleration does not change, so acceleration time graph remains the same. The ones that are a little bit complicated is the one here, displacement time graph. The velocity time graph is also simple, but we'll study it all the time. So for an object that is dropped, this is we are looking into these shapes of the graph. These values will input them, you have calculated them using the four equations of motion. Obviously, you input the value of final velocity when the object reaches the ground, and what time was it, how many seconds later did the object reach the ground. So you can input them. The same applies the maximum height of the maximum distance traveled by the object, to input it there. So that's what this thing will look like. I hope I hope we are still together. I'm not moving too fast. So this is how your thing will look like. Now let's look at for an object that is thrown downwards, because there's different scenarios. An object that is thrown downwards, this graph, velocity time graph, remains the same straight line. It's just that it shifts. It will shift. For down positive, it will shift upward. For down up positive, it will shift downwards. These ones, they remain the same if the object is thrown, and this one changes a bit. It changes a bit. So let's study that part of motion. Object that is thrown. It is thrown downwards. The object is thrown downwards. So we expect initial velocity is not zero because it is thrown downwards. And final velocity is not zero. The velocity is only zero when an object is dropped, or when we study the other part later on. So let us do displacement time graph. Displacement time graph remains the same. Nothing changes with it. It remains the same for an object that is thrown upwards and that is thrown downwards. The shape of the motion pretty much remains the same. The only thing that changes is the velocity time graph. So now the velocity time graph, let's choose up or not down, down, positive. This object is thrown. The shapes are more important. Remember, as I said, the other numbers we calculate them. We choose down positive, so it means you throw it down, it leaves your hand with a certain velocity that is not zero, and it is positive. So it starts there and it's a straight line. Okay, my graph, I was supposed to extend it that point. This point there will be the velocity final. When it reaches the ground, this will be initial velocity, and this will be final velocity when it reaches the ground. Remember, it starts above the ground because when the time was zero, when the time was zero, the velocity of an object was not zero. It was thrown downwards, so the initial velocity is not zero, and this will be the final time when it reaches the ground. That is that. So it means now when you choose up positive, when you choose up positive, so it's going down, and you throw it, velocity vector will look like this. This is vi, and the v final will be the value somewhere there. Acceleration time graph and acceleration time graph as well as the displacement time graph, they pretty much remain the same. The velocity time graph is the one that changes. It just shifts on the y-axis. It moves up. Now there's something that we should not forget to mention as we are starting this. Let's go to, I want you to get it now and keep it in check all the time. Okay, let's repeat the velocity time graph. With the velocity time graph, I'm gonna start with the one where the object is dropped. When the object is dropped, remember its initial velocity is 0. When the object is dropped, its initial velocity is 0. So as it moves, as it goes down, because it's being pulled by acceleration of the value 9.8 meters per second squared, the value of the acceleration is 9.8 meters per second squared acting on the object. So the velocity of this object will increase downwards. Any object that is coming to the ground, its velocity increases. It keeps on speeding up. This will be some time t. So as it moves downwards, the velocity increases. Notice that when the time becomes a certain value there, velocity will increase to a value there. Velocity is directly proportional to time. As time increases to become another value somewhere there, the velocity will become a value that is above the initial value. So velocity increase and it becomes a straight line. So what is important mostly, it is the shape of the velocity time graph. So it looks, the shape will look like this for velocity time graph. But when an object is not dropped, remember when it's dropped, it starts at 0. When the time is 0, the velocity is 0. But after some time t, the velocity will have increased when it reaches the ground. It's a straight line because it's given by this formula. V equals to acceleration change in time. This will be your initial velocity, is the value that will be on the y-axis always. So you're plotting this against time. You're plotting velocity against time. So already when you look at that formula, a lot of things come into your mind. It's just that it's not rearranged carefully. Let's rearrange it. Let's rearrange it the same way you do it, Gomez. If you in maths you are drawing a graph that looks like this, y is equals to mx plus c, where this is what you plot on the y-axis, this is your y-intercept, this is your x-axis, the values of x that change with respect to y, and this is your slope, right? So that formula, that v final is equals to v initial plus acceleration change in time. It's not rearranged carefully. For if we rearrange it properly, it's going to be v, this part will go to the other side, and it will be acceleration change in time plus vi. Remember, you can, addition is commutative. You can reverse them. 1 plus 2 is the same as 2 plus 1. Will give you the same answer. So this will be the final velocity. We just rearrange this formula, it becomes this. Now this becomes your y-axis, it's your y, and this becomes your m, so it corresponds to m. It's your slope in other ways, and this becomes what you plot on the x-axis. You can see on the graph now, we have on the y-axis we have velocity, on the x-axis we have time, and this is your c value. This corresponds to this value, your c value. When the object starts from, when it's dropped, this value is 0. So you're only plotting these two. And notice that these two are directly proportional. When you increase this must increase. So that's why it is a straight line. Another thing you see from this, when you rearrange this formula here, is something that I wanted to talk about. Now let's add it on the graph. The slope or the gradient, slope is equals to gradient. It's one and the same thing. The slope of the velocity time graph is always, look at it, when you look at this formula after we rearrange it, it's always acceleration. So it means it is 9.8 meters per second squared. That is the slope of the velocity time graph. Anyway, velocity time graph, when you calculate the gradient of this line, you must get acceleration. After we rearrange this formula, this is what we see. Now, another thing that we learn from here is the area. I want us to deal with all of them now so that we keep in mind, because the area under the velocity time graph. So area under the velocity time graph will be displacement. I'm just going to write it like that. The area under the velocity time graph is always displacement. So area under the velocity time graph is always displacement. This is the area under this graph. So it means under this one, it will be this part. This must be between the line of the graph and the x-axis. The line of the graph and the x-axis. So that will give you the displacement. The area under the velocity time graph is displacement. And remember, this is a triangle, so the area of this graph is calculated using from analytical geometry. This will be half base multiplied by height. So it's 1 over 2 multiplied by the distance between the two, multiply also by the height. So just keep that in mind. So in the velocity time graph, the area represents this displacement, and the gradient of the graph will represent this, the acceleration. I hope that makes sense. I'm not going to talk more about the displacement time graph. I'm interested in this one. The slope of this graph is 0 because this graph is not increasing or decreasing, the acceleration time graph. So the slope of this graph gives us nothing. But the area under this graph will always give us the velocity. So the area under this graph, area gives us velocity. The area under the acceleration time graph will give you velocity. So let's see now for an object that has been thrown downwards. Still maintain the same. The gradient of the graph is the acceleration is 9.8 meters per second squared. But the area under the graph, which is going to be this part, will give you the displacement, the distance traveled by the object. So always keep it in check and as you're studying it. I think I'm done with this one. I want to move to the next one. I want to move into an object that has been thrown up and then it came to the same height. Let's change and check that one. So this what happens when an object is thrown upwards and comes down. When you throw an object up, so object, let's so this object, someone has a tennis ball or a coin or anything in his hand. He throws it up, and then from the same height he collects it. So this object, if say for instance that where it lives will have that as the ground, its ground point, because that's where it starts. It starts moving. We have object, it moves up, it comes down to the same position. Because you throw it up and then you collect it for the same position. So the shape of the motion of an object will look like this. Now for this type of motions, there's a lot of things you need to conceptualize. Number one, keep in mind we said acceleration of the object does not change all the time. It remains 9.8 meters per second squared. So it means anywhere in its motion, when this object is moving up and then coming down, the acceleration of the object is 9.8 meters per second squared downwards. Always, doesn't change. So even at this point, so this is the starting point, point A, this is some point B, and this is point C. Anywhere at point A, the acceleration is 9.8 meters per second squared downwards. At point B, the acceleration of the object is 9.8 meters per second squared downwards. And at point C, the acceleration is 9.8 meters per second squared downwards. So anywhere in the trajectory of this object, acceleration does not change, remains the same. So keep that in mind and check it. So acceleration is the value that does not change. However, there's something that changes. This is not an object that just went down or it went up only. It's an object that has been thrown up and comes down. Normally when you throw an object up, it will go up and comes down on the same line, right? But notice that does not factor in the issue of time. The time is moving to the right. So if an object is going up and comes down on the same line, that says that the time did not change. For the time to change, it means consider a situation where I move my hand up and down and then I pull this paper to the left because time is moving to the right. So this will have if we move it correctly, this will have a motion that looks like this. So that's why I have my motion looking like that, because the time factor, this is the time is changing, but the object, obviously the object is going up and down on the same line. but the time is changing. So this factor it factors in the issue of time. For this type of motion, velocity here is not zero. So velocity initial, this will be initial velocity, is not zero. Final velocity at this point C, is also not zero. So when you throw an object up, it comes down. When it comes down, its final velocity is never zero. It cannot be zero. It's a value, which we'll talk about not long from now. So it's just know that the velocity when the object leaves the hand and when it comes back to the hand, it's not zero. Velocity is only zero at point B, because this is where the object makes its return. It reaches maximum height, stops a little bit, and comes back down. So velocity at point N at maximum height, always the velocity will be zero. We'll have velocity value as zero, always maximum height. But anywhere between A and C, A and B, velocity is not zero. Between B and C, velocity is never zero. It's only zero to point B. Velocity is also not zero to C, is also not zero to A. So initial velocity will be a certain value. If initial velocity was 10, say VI is 10 meters per second up. So it means final velocity will also be 10 meters per second. But now they cannot be positive, both of them. We need to choose direction. This one, the object is going up. The object is going up, and the object is coming down. Remember, velocity vector is always in the same direction as the direction of motion. So the object is going up, the velocity vector is facing up. There's no direction. Anywhere between A and B, the velocity vector is facing upward. It just decreases. As the object goes up, velocity decreases. As the object comes down, velocity increases. So the velocity, if we choose up, say we choose up positive. Okay, I'm just choosing up positive for this. So it means this part will be positive 10 and this side will be negative 10. It will be minus 10. Value of velocity at A and C is the same because the same height, but it only differs the direction. So this also says that anywhere say I consider that point there, I make 2 points. This is the same height above the ground. The same distance above the ground, the 2 points. The velocity at these 2 points will be the same. The only difference is the direction. This one is facing up and that one is facing downward. And that's how we have it. We have velocity like that at 2 points the same, but one facing up, facing downwards. The displacement time graph, which is if you've drawn your graph like this, your motion like this, the displacement time graph looks like this. It's quite simple one now. It looks the same way. It looks the same if you choose. This is when you choose up positive. I'm choosing up positive, so I'm keeping it like that. So this is your time in seconds, and this is changing y in meters. So a displacement time graph will look like that one for an object that is thrown and collected at the same height. Notice what changes now. The velocity time graph, remember, it has to be a straight line. Velocity time graph has to be a straight line. Velocity, initial velocity is 10, and final velocity must be 10 because it's coming to the same height. Velocity at this point is 0. This side velocity is positive, this side is negative because you choose up positive. So the velocity time graph, okay, this was displacement time graph. The velocity time graph is the one that is quite important when we're going forward. We choose up positive, so it means the initial value is 10. So it's some value there, which is 10. As time moves by, after some time, velocity is 0. So after some time, as time increases, velocity is 0 because the velocity decreases. Let me write velocity in meters per second and time in seconds. So velocity decreases to 0 and then increases in the negative direction. So we get velocity at this point to negative 10. Initial velocity was 10, final velocity is minus 10. And then the velocity at this part is where is at point B. So this will be point A, point B, and point C. At point C, velocity is still 10, but in the negative direction. At point B, velocity is 0 because that's the maximum height. It's quite tricky. It's a straight line that goes down, but it must be a straight line. It doesn't come down and go up because we are choosing direction. So this part is positive, and as the object goes up, velocity decreases. So as the object goes up, velocity decreases. Notice that. Look at my hands. As the object moves from point A to point B, the velocity decreases to 0. Now, as the object moves from B to C, the velocity increases to negative 10 in the negative direction. So that's how the velocity time graph would look like if you have chosen up positive. So if you choose down positive, it's the same straight line, just that now it starts here, it goes up to that point. Notice that for positive motion and negative motion, whichever you choose, imagine a situation where you have a mirror here on the x-axis. So this part will be somewhere here, and this part will be over there. So it's a straight line moving in that direction. So that will be the velocity time graph. I'm not going to go into the acceleration time graph. Remember, we said it's a straight line. Does not change this one. It's a straight line parallel to the x-axis. And this is what happens with the motion of an object that is thrown up, then comes to the same point. If an object is thrown up, it is thrown up when the thrower is supposed to collect it at points, leaves it to go to the ground, to a point lower than where it started. Then this graph simply goes down like that. So let's have a motion like that. So now we have an object thrown from point A, goes maximum height, point B, and then it passes. So we have a point there. This is the point where it was supposed to be collected, but then say the person misses it. So the shape of motion will look like this, and the point of interest will be point A, point B. We can include point C here and have point D over there. It's fine. Maybe it will help us to use point C later on. The displacement time graph, the same. It goes up, comes down like that. The velocity time graph, the same straight line. We're choosing up positive, so it's a straight line. But notice now that the value here won't be equal to the value there, because now the object went lower than it was. So as it moves down, velocity was equal at point A and C. Now as it continues moving down, velocity increased. That's why I decided to have a bigger part. Now let's address the issue of, again, the issue talked about earlier on of acceleration and of area and the gradient. The area of the gradient of this graph must be 9.8, still acceleration. So the gradient of this graph is acceleration, which is 9.8 meters per second squared. The area under the graph, this between A and B, gives you the displacement from A to point B. So this will give you area number 1. This is area number 1. It gives you the displacement between point A and point B, because this is the area between A and B, between the 2 points. Gives you the displacement there. Then the area on this side, this is area number 2. This will give you the displacement from point B to point C. Notice the displacement going up is positive, is increasing. The displacement coming down is negative. And the area of triangle is half base height. So it means this part and this part are equal and they're in opposite direction. So it's 0. Does it make sense? Yes, it should make sense. The object, when you look at the displacement time graph, it should make sense. The object started at this position. It returns after some second later at the same position. So the displacement is 0 in that case. But for an object that went up and came down, the area on this side won't be won't be equal to the area on the other side. So this is a part that we'll deal with as we solve questions. Just keep that in mind and keep it in check. I hope that gives us an idea of what we are dealing with in this chapter. Now let us have one question paper and solve questions based on this thing. See how we solve questions. What is important is knowing the strategy of solving questions. But now we understand the issue of graphs. Mark graphs now, those are easy marks. If you know the shape, at least you have secured 1 mark. The next thing, you just put in the values that we have calculated. Even if they are wrong, put those values onto your graph. You will be awarded marks, positive marking. All right, now I have this from one of the past papers. You can have questions. The first questions from a textbook, it's fine. But I have this from one of the past papers, and I want us to look at it. How we solve. First step, I'll solve it with you. Just keep it in check and stop me when I'm moving fast. There's no, let me see, there's no graph, but there's one question excuse me, there's one question of a graph 3.3, but we'll get to it. So let us start at the beginning. It says, no, it's not visible on your side. Is it visible now? Yes. I believe it's visible on your side. Now it says an object is released from rest from a point X above the ground as shown in the diagram below. It travels the last 30 meters, which is between point B and C, in 1.5 seconds. So it means the time between point B and point C, change in time, is 1.5 seconds. For an object to move from point B to point C is 1.5 seconds. So we don't have the time. They did not give us a time between point B and point C. Point X and B. We are also given the distance between B and C, but we are not given the distance between, so it means we don't have enough information. Change in Y is not known between point X and B. So those keep those things in check. What is important is analyzing the situation. When you analyze the situation, you collect data. So let us see. Between point, when you consider your motion, they made it easy. They put point X, B, and C. Between point X and point B, I'm gonna write it like that. Between point X and point B, let's write everything that we have. Between point X and point B, we don't have time. That's what you noted first. We don't have time. Between X and B. So this will be our initial. So this X will be our initial, and then B will be our final. So let's keep it like that. But displacement between X and B, we don't know. So we don't know how high is X from B. We do have initial velocity. Initial velocity is the velocity at X. We do have initial velocity at X. We have it. They say an object is released from rest. So it's the first scenario that we dealt with earlier. So it means initial velocity is 0. Initial velocity is only 0 in 2 points of projectile motion, people. It's only 0 when the object is dropped, or only 0 when the object is thrown up to maximum height. So keep that in check. This is what we have. When an object is dropped, velocity initial is always 0. When an object is dropped, those are the only 2 points. Anywhere else, velocity is not 0. So don't assume 0 when you think you don't have enough information. Don't think it is, then one of them becomes 0. No, write it down nicely what you don't have it. It's also 0 to maximum height for an object that is thrown up and comes down. So even this one is thrown up, it comes down to it is thrown up, passes point B, and C goes to lands at D. Velocity is 0 there. And for this one, object is thrown up, collected at the same height, velocity is 0 there. Those are the only 2 points, no any other point. So keep that one and remember it all the time. Remember that all the time. Let's now continue collecting information between point. Remember, there are 5 physical quantities. Yes. Always write all 5 of them. There are 5. There's initial velocity, final velocity, displacement, time, and acceleration. Write all of them. All of 5 of them. The 5th one is always given. It's 9.8 meters per second squared downwards. And I'm writing it in red so that you don't make mistake there. The other 4, we have to find them out. Always we have to calculate them. The other 4, we always have to calculate them. So let us go step by step. We have 3 of them, so we need final velocity. Final velocity. Final velocity, when the object starts at X, we considering between point X and B. Our final weight will be at B. We don't have that value. In the statement on the diagram, that value is not given. Now we're analyzing the statement and the diagram. And the acceleration, how much is the acceleration? Between point X and B. How much will be the acceleration? It's always 9.8 meters per second squared downwards. I'm writing the direction intentionally, always. You'll see when we do calculations, why is it always important to write the physical quantity together with the direction, except time. Time has no direction. So la between point X and B, there's a lot of things that we don't have. We don't have 3 of them. You are allowed not to have 2. If it's more than 2, you can't solve anything. We cannot solve a problem using point X and B. So point X and B, right now, it renders itself less useful. So it's not useful to us. So let's consider motion then between point, we are changing now, between point B and C. So if we're considering B and C, it means we are starting at B, we are stopping at C. We are considering B and C. Let's write all the things. I'm going to give you a few minutes to try and write down 5 physical quantities: change in time, change in y, change in time, acceleration, VI, and VF. There are 5 physical quantities. Have some time, try to write everything. Let's see if we have enough information there. Remember, we are allowed to not have 2, not more than 2. If there's more than 2 physical quantities that are not known, you cannot solve a equation between those 2 points. And vertical projectile motion is solved between 2 points. You choose points that you consider always, and it works nicely. It becomes simple. So yeah, I'm waiting for you to write down the 3 to analyze, make your analysis and write down all 5 of them. This one, I also know it. Let me write the one that I know. Then you can figure out the other ones. This one I also know. So figure out the other 4. I believe you are done now, because it's quite easy. When you look at the diagram, actually the analysis is all in the diagram. The displacement between point B and C, it starts, so it will point from A to B to C. I mean from B to C. I'm writing my direction intentionally, because we said displacement, wherever it starts, you make a point, then line stop a corner. Where it stops, you put an arrow there. So the direction of the displacement is 30 meters and it's down. It's a vector quantity. I'm writing the direction always. That will help you when you start doing calculations. And the next one is time. The time is 1,5 seconds. It's given here. It says it travels the last 30 meters in 1.5 seconds. So the time that is given is between point B and point C is time. Time has no direction. Notice I'm not writing direction. Now the initial velocity will be at point B. The initial velocity at B, I don't know it. Remember, B now becomes initial when I'm considering B and C, because that's where I start and this way I stop. So it becomes initial. I don't know it. This is velocity at B. So let me write it, velocity at B. At B is not known. This will be velocity at C. And this is also not known. When the object reaches the ground, it does not stop. It does not stop. No object becomes, the velocity of the object where it lands is not 0. You know where the velocity is 0. The velocity is 0 in 2 points only. Yeah, yes, that the one that the person who's saying, Cindy, who's saying velocity at x is not 0. Velocity at x is 0, yes. Notice what I did. I'm separating. Look at here. This is between point B and point C. This is point X and point B. I'm intentionally ignoring between X and C because there's missing links. There's parts where there's information that I don't have between X and C. I don't have the direct distance, the displacement between X and C. So that makes my solving this question very difficult. You only have the distance between B and C. But between X and C, you don't know the distance. It's 30 plus something. So we don't assume that the noise is 30. And I also don't have time between X and C. I have the time between B and C to 1.5. So X and C, I'm ignoring it intentionally because it's not helping them. It's not helping. But we can write it on the side. We can write it on the side. We've written between x and b. We write all the information we have. When you solve vertical projectile motion, choose points starting from this to that one. Don't make it too long, and make sure that the 2 points that you choose, they give you enough information. X to B is not giving me enough information. There are 3 unknowns. The velocity is 0. Yes, initially velocity at X is 0, but velocity at B, I don't know it. Displacement between X and B, I don't know it. The time between X and B, we don't know it. So there's 3 things that we don't know. That is very dangerous. We don't know these 3 between X and B. Now I'm considering B and C. Between B and C, the displacement is given between B and C is 30, and I'm writing it downwards because I'm starting there, stopping at B. I mean at C. The time is 1.5. It is given in the statement. So these 2 are given in the statement. I have them. The acceleration we know with this value remains 9.8 meters per second squared downwards always. The initial velocity is the velocity at B. So notice I'm writing on the bracket like what is velocity at B. So it's not known. We don't know it. We did not know it this side. We will not know it this side. So we don't assume that velocity at B is 0. This is it's in the middle of, it's not in the middle necessarily, but within its motion. So the velocity is more than 0 now. The velocity at C, this is my final position. I also don't know it. Notice that I wrote A, B to C. So B to C, this must be an arrow. B to C, my initial is at B, my final is at C. The small I and small f, consider them. I hope that explains it for you, Cindy. Yeah, so we have this information, but between X, we can write that between X and C, we don't have enough. We don't have displacement. We don't have time. We have velocity initial at X, which is 0. At C, final velocity, we don't have it. Now there's already 3 things that we don't know. Solving a question using this will be very difficult. So let's continue further and answer the question. Now we've made our analysis. Now we can go answer the questions. 3.1. 3.1 says that name the type of motion described above. The motion of an object described above. What is the motion of the object described above? 3.1. Anyone with who can help us? Anyone who can help us with this one? Anyone who can help us with 3.1? Answer to 3.1. Yes, I agree with you, Flames. The motion, this is free fall. The correct answer is free fall, and you get yourself a mark for writing free fall. Yes, Nomfundo also correct free fall. So we have it. The motion is free fall. Now the next question. Now it says calculate the magnitude of velocity of the object at point B. So which part are we going to consider? Which part are we going to use? Are we going to use X to B or B to C? Whatever that we use should have enough information for us to solve the question. Which one are we considering? X to B, B to C. Yes, I have a YouTube channel. The handle is the same as this one, but when you click on my profile, my TikTok profile, there's a button that will direct you to my YouTube account where we have uploaded some of the videos. So there's a button that looks like this, just next to follow us, and there's a button that looks like this. When you click on it, it takes you directly to my YouTube link. Yes, correct, Cindy. We are using B2C. Non-Dumiso and Cindy, they have it that we're using 3.2.1. We are using B2C. So I'm writing intentionally so that I remember you're working on marks, né? So everything you do must be wide awake and be intentional about your answers. So this is what we have. Now once we have this, the next thing that comes in after this is choose a direction. The object does not go down, it does not go up, it only goes down. So it means we are going to take down as positive. It makes calculating easy. So I'm writing there the arrow there that I'm choosing downward as positive. Now after this, the next thing that you have to do is go choose the correct formula from the formula sheet. Now when you choose the correct formula from the formula sheet, there are 4 formulas. You are looking for velocity at B. You don't have velocity at C. So it means you must avoid any formula that contains final velocity in it. Any formula that contains final velocity in it, you must avoid it. Normally, there's only one formula like that. Let's go check in the formula sheet. This is the section that we're looking. This is the section that we're looking for. This formula, first formula, has final velocity, initial velocity, and I don't have both of them, so I cannot use it. I'm ignoring it. I'm running away from complex mathematics. Ne? Second formula does not have, it has final velocity, initial velocity, and I don't have both of them according to the information we have between B and C. Remember, these are unknowns, both of them. So it means these two formulas, I'm ignoring them. I must ignore them. I'm going to formula number 3 and formula number 4. I'm checking formula number 3, displacement, initial velocity. I don't have the initial velocity. Final velocity is not here. So it means I can choose this formula because it does not contain both initial and final. This one, the last one, contains initial and final, and I don't have both of them. So my math will be very complex. It means I will have to solve Martinez equation, take two formulas, and you're working for 4 marks. If it's 4 marks, there's one formula that will take you to the answer. So we are taking this formula, changing y equals to vi, acceleration changing time. Always when you choose a formula, that's what you do. Always. So this is the formula we're choosing, changing y equals to vi, change in time, plus 1 over 2a change in time squared. You've made a right choice of formula. You get a mark, you get awarded the mark for choosing the right formula. So make sure when you choose the formula, you choose the right one. So let's substitute. We choose down positive. Displacement is going down, so it means it's going to be positive 30. Initial velocity is not known. I leave it as vi. I don't even write positive or negative. Just write vi. For something that we don't know, do not write direction. The time is 1.5. Time does not have sign. So time is always positive. The scalar quantity is always positive. Plus 1 over 2. The acceleration of the object is 9.8 downwards. It's downwards, so I'm taking it as positive, also 9.8. And then I substitute the time again, 1.5. This must be the same time. So the value you have there must be the same value there. And don't forget to square. And from there, you do the maths. By so doing, you have 3 marks already. You have 3 marks. Out of 4, you have 3 marks. So now you work out the maths to get the final mark. So you have 30 on the left equals to, now you'll have 1.5 vi plus, you do the maths of this one. Don't take your calculator and add those numbers. So you have 1 over 2 multiplied by 9.8 multiplied by, in brackets, 1.5 close bracket squared. Then you get 11.025. So you get 11.025. Now we are trying to isolate vi because we're looking for vi. So let me take this number to the other side. Now I have 30 minus 11.025 equals to 1.5 vi. Then you subtract the two. Subtract the two, you get 18.975 equals to 1.5 vi. Now what do I do to isolate vi now? I want to make vi the subject of the formula. How do I do it? How do I isolate vi? Thank you. Yes, we transpose 11.025. In the next step, what do? We want to isolate vi because we're looking for vi. What do we do? Next step, I want to isolate vi. When there's multiplication between the two, you divide. Ne? So we divide both sides by 1.5. What you do on the left, you must do it also on the right. What you do on the right should also be done on the left. So 1.5 divides 1.5, and I'm left with, this side I'll only be left with vi. On the other side, I divide that number by 1.5. I get 12.65. Please let me know if you're getting a different answer. I got 12.65. When you divide that number by 1.5, you get 12.65. And this is vi, so it is in meters per second. So it means, therefore, vi is equals to, I'm just rewriting it properly now. Vi is equals to 12.65 meters per second. Now let's go look at the question again. Once you've done this, you are sure of you've done your math correctly. But reread the question again. Make sure that you understand what the examiner is asking for. The examiner is asking for the magnitude of velocity. He did not calculate velocity. He did not say calculate the velocity. The examiner said calculate the magnitude of velocity. So it means you don't have to write direction. If the answer was negative, you rewrite it as positive. You don't write direction. If they want magnitude, and this is how you get awarded marks. 1 mark for choosing the right formula. The choice of formula always has a mark. Choosing the right formula is 1 mark. Substituting 30 on the left is a mark alone. Now putting the values, all the values on the right correctly is another mark. You have 3 marks. You work out the maths. Don't worry with the maths. Do it step by step. It's not a race. Ne? You are working you want all the marks on for yourself. So work out the maths nicely step by step. Don't make a mistake and get the final answer. Those that are good with maths, they simply go from this part to this part. They do it in a calculator. It's fine, but I'm showing all the steps for everyone to see how do we get to the final answer. And this is how your question for 3.4 is. And I think that is 4 marks. Yes, it's 4 marks. You get awarded 4 marks. And this is how it looks like. I'll allow you to copy Engani. Then we move to the next question. Now the next question says calculate the height at point X above the ground. Now point B to C will not help us anymore. It means we must choose points that are going to help us. We can choose X to C or we can choose X to B. But the danger with choosing X to C, there's a lot of things that I miss. There's a lot of misinformation in between. So I will not advise to choose X to C. Unless you want to flex your mathematical muscle, you can choose X to C and solve smartness equation, make it more complex. But we want marks, né? We don't want to complicate this thing. So we are going to choose point X to B. Remember, after calculating this, now we have extra information between X and B. Because this number X is between B and C, so it's a value at B. It's a velocity at B. It is initial between B to C, but it is final between X and C. So let's write down everything from X to B. From X to B, let's write down everything from X to B afresh. Can I move it up now? Are you done? So from X to B, I'll keep the question here and have another paper. From X to B, velocity at X, this will be I, my X will be initial, and my B will be final. Remember, always choose 2 points. Oh wait, someone is not done. Let me return that, sorry. Yes. For those that are still copying it, I'll allow you to copy it. You'll just shout when you're done. Before I move to the next question. Let me know when we are done so that you can move to the next question. All right, yes, you are done. I believe everyone is done. Now I'm going to remove the whole thing and I'm rewriting new information between points X to point B. Initial velocity will be the velocity at point X. Ne? The velocity at point X, we don't know it or we know it. Final velocity will be final velocity at point B, because I'm choosing carefully X to B. Always, all the questions will do them like that. And then displacement, I must write displacement, I must write the time between X and B, and I must write the acceleration of the object between those 2 points. But this one I can give it to you for free, and then you will try to write the other ones. This one is 9.8 meters per second squared down. It's always downwards. Acceleration is always this value, does not change. Keep it in mind every time you get a paper and then you see question 3, projectile motion, acceleration is 9.8 meters per second squared. Does not change. Now, and I said to write down these physical quantities all the time before you solve the next question. It will help you a lot. Don't rush through and choose the wrong formula, because I want you to get the marks for the right formula. and substitution. So initial velocity, this is my initial will be, if I'm considering x to b, this is where the object started. It started at x and it's coming down to b. It's not going up, remember, it's coming down. So it means this will be my initial, this will be our final. So our initial velocity is 0 because the object was released from rest. So initial velocity at x, this is velocity at b. So let's write velocity, no, velocity at x. What is the velocity at b? That will be final velocity. How much is the velocity at b? While you're still looking for it, I'm quickly going to check the displacement between x and b. Do we have it? Oh yes, Flame says it that the velocity at b is 12.65 meters per second. And the direction, what is the direction of this velocity? Let's give the value plus the direction. Yes, I forgot to mention that. Excuse me. The velocity at b is 12.65 meters per second. Now, what is the direction? Correct, Cindy, the direction is down because the object does not go up and down; it simply goes down. So, for all all of them, write the direction except for time. Write the direction for all of them all the time except for time. Unless the value is 0, you don't write. There's no direction when the value is 0. The displacement, how much is the displacement between x and b? This value is not known. We don't know it. We did not know it before. We don't know it now. The time between x and b, we also don't know it. So we are allowed to have at most 2 unknowns. If there are 2 unknowns, then we are fine. We can solve the question. There is a formula for that will help us to solve that. Now the question says, let's go back to the question again. It wants the height. So it means the examiner is trying to get us to calculate this one. This is what we are calculating. It wants the height, but we care about the distance between x and b. But now they want the height from from c to x. The total height will add 30 once you get it. But now let's concentrate on the distance between x and b because that's the part that is missing. Which formula do we choose then? Because the next step, okay, with direction before formula, direction that we choose as positive, this object is not going up, it's coming down only. So let's choose down as positive, and now go and choose the right formula. The formula that we choose, we are looking for changing in y, so we must avoid anything that has time because we also don't have time. So we're avoiding time. So we go to the formula sheet, avoiding time. Which formula do we choose? The first formula, it has time in it. Nope. Formula number 4 has time in it. Formula number 3 has time. Only formula number 2 has no time. So we write formula number 2. This is the right choice of formula. We choose the formula and then we continue. So we have final velocity squared equals to initial velocity squared plus 2 times acceleration change in y. We've made the right choice of formula. We are guaranteed that mark. The next step is to input these values into the formula, substitute them to secure more marks now. So final velocity is 12, is downwards. So we're choosing down positive is just 12.65 all squared equals to initial velocity was 0. We square it. We can just write 0. 0 squared is just 0. Multiply by 2 times acceleration. The acceleration is 9.8 meters per second squared down. Multiply by change in y. Change in y is what we are looking for. So we substitute all the values and then we are only left with change in y. Notice I put all of these 2 values positive because it's down and down. So it means we're choosing down positive, and since we're choosing down positive, I'm writing both of them positive. Now let's do the math step by step. So we have 12.65 squared. This will give you, it gives you a very big number, but let's write it down. I'm doing step by step. 160.0225 equals to 0 squared is 0, it disappears. Then this one goes away. Now I'll multiply 2 by 9.8, that will give me 19.6 delta y. Now how do we make delta y the subject of the formula? Let's make delta y the subject of the formula. Remember, they are multiplying each other, so it means you must divide. must divide by 19.6, divide by 19.6. This one, it divides each other, and then get 19.6, delta y equals to this value on the right divided by 19.6. This from my side it gives me 8,14. 16, excuse me, 8,164. 8,164. This is displacement. The unit for displacement is meters. So I'm rewriting it carefully. Delta y is 8.16 meters. I don't think we've answered the question fully. The question says the height of point X above the ground. So it means now I'm going to say height is equals to the value that we have calculated, 8.16 plus 30, because now 8.16 is the distance between X and B, but they want the distance between X and C, so I'm adding 30 on it. We are adding 30, and then we get 38,16 meters, and there you get your 5 marks. Let's see how your 5 marks goes. The first mark is for making the right choice of the formula. The second mark is for the left-hand side substitution, and the right-hand side substitution is marked separately. Left and right will be marked separately. And then you work out the steps, you get your final answer. We don't mark it because you're still going to use it in the next step. So you get a mark for adding 30 and getting the final answer. So we have 5 marks for this question, and this is how you score yourself 5 marks. Let's wait for everyone to copy, to write it down. And yes, you are allowed to check with your friends tomorrow at school, and also ask them to join us tomorrow after class later in the day. I'm gonna check my load shedding schedule before I give you the times. That gives us the answer to question. This is question number 3.2.2. So it's 3.2.2. Question 3.2.2. YouTube channel is at JNJ Lem. That's YouTube channel, but find the link is on my TikTok account. There's a button on my profile that looks like this. That button takes you directly to my YouTube account. When you press that button on my account, it takes you straight to my YouTube account. So check it out. There are videos there. It's just that we're struggling with load shedding here where I am right now. So I'm struggling to upload the video. There's a 2-hour video that I'm trying to upload on YouTube on this chapter, and more questions. But now since you are here, it means you will be assisted here. I'll try to make the other videos not too long so that they can upload quickly. Yes, I teach both physics and maths, physical sciences, that is physics and chemistry, as well as mathematics. So we are going to do organic chemistry throughout the course of this. Actually, I'm done teaching organic chemistry in my school and both the chapters. But no, we're not done. We're just finishing. We are doing the last part, the chemical reactions. But we are going to, during the course of this week, we are going to do organic chemistry. We are going to start it from the beginning slowly and do everything on it. We do it step by step, very slow. We don't rush it, and so that you understand it carefully, especially naming organic compounds using IUPAC naming system. That is, I feel like that is important. Is everyone done? Can we move to the next question? The next question is the last question. Actually, it's for 3 marks. There's a statement before the last question, so let's read the statement first. Always incorporate new statements to our question. So it says, after hitting the ground, so the object is coming down, it hits the ground at point C. After hitting the ground, the object bounces once and then comes to rest on the ground. So I'm not just gonna let's answer the question, then I'll come back to what I wanted to say. The question says sketch the acceleration time graph for the entire motion of the object. I believe this you can try it. Let me give you 3 minutes to try it. Your 3 minutes begin now. So let me give you 3 minutes to try the sketch of acceleration time graph. This is one of the easiest graphs we have. Try it 3 minutes. So right now is 15:36. I'm giving you 3 minutes up until 15:39. It's for 3 marks. 3 marks, 3 minutes. Um, I believe you are done, or you are still working on it, but you still have 2 more minutes to answer the last question. You have 2 more minutes to answer the last question. 2 more minutes to answer the last question. For those that just joined now, please follow me on, subscribe on my YouTube channel. The link to the YouTube is on my account. Look for a button that looks like this, or you can search J&J Lem. It takes you directly to the link to my YouTube channel. There's videos there's some videos there, and during the course of the week I'm gonna try to upload more, so that if you, in case you missed the live session because of load shedding, you can check out something on YouTube. Let's see how many minutes more left. 1 more minute, then we discuss it. Please send us a like, and also subscribe on my YouTube channel. This is gonna help you a lot for your grade 12, and for those that are rewriting grade 12. It's going to help a lot. Those that are rewriting in June, please keep us in check all the time. Check our TikTok and YouTube channel, and get yourself ready. Tell your friends. Yes, also tell your friends about our channels, TikTok and YouTube, so that they can also join. We want everyone to pass physics. Yeah, now it's time is up. Let us check how you're supposed to draw it. What is more important, they say acceleration time graph. Now you must know that you are plotting this against this. Your time is on your x-axis, so your graph would look something like this. This is time in seconds, and this is acceleration in meters per second squared. Now, with all this time, we've been choosing down positive. Even in the previous sub question, you chose down positive. So let's keep the same direction that we are making. Down positive, you're making down positive. So it means the value of our acceleration is positive. When at the beginning of everything, the value of acceleration will be here, and it's just going to be a straight line. And this will be 9.8. And notice that it's just a straight line. It Even though the object bounces, they did not mention the issue of time delay here on this question. But normally when it bounces somewhere here, it hits the ground, and then it hits the ground again on the last part and stops. But acceleration does not change; it remains the same value. For your grade 12, it remains the same value. Even though we know that acceleration depends on the radius, on the distance between the object and the center of the Earth, but we take it to be 9.8 throughout, and so therefore it does not change. So your graph should look something like this. We don't have time for the first bounce. We don't have time for the second bounce. It's fine. We don't have to indicate the numerical values on the x-axis. What matters is the shape. So you get okay, let's label it now. It's going to will be acceleration versus time. And you get 3 marks. You get marked 3 for these 2 marks for the shape of the graph and the fact that you've indicated on the y-axis that value 9.8. It's another mark. And this is 3 marks. And there you have it. That brings us to the end of this question. I'm not sure if you still have energy for more, but I have I have many questions that we can discuss. Actually, I'm looking into this one. For those that are still trying to draw this. I hope that helps. Yes, okay, so you just joined now. We are doing vertical projectile motion. This is what we're dealing with, the issues of free fall. Do you have exam next week? I don't know. I believe the examinations they should run the supplementary exam. It's written in June. Okay, in South Africa, it's written in June. Supplementary exam will be written in June, July supplementary examination. So no, May, June. Around May, June, there's an exam for those that are writing supplementary. I'm not aware of any that is taking place right next week. Yes. So let's now try to do the other one. Let's do the other one. Let's have different paper now. Can I remove this one? Are we done? Are we all done copying everything? Can I remove this one?